Welcome to qnawire.
In this problem, we are asked to determine the formal charge of chlorine in hypochlorite and perchlorate ions. It also says to use resonance structures where chlorine has an octet. I thought that was interesting because, of course, the hypochlorite can't have a resonance structure because it's only two atoms involved. And for the perchlorate, we can't have resonance structures because chlorine has to have an octet. And any resonance structures doesn't have chlorine with an octet. So first I'm going to draw the Lewis structures for each. And this one's pretty simple. Since this has one extra electron, this is it. And chlorine has 7 valence electrons. Oxygen has 6 valence electrons. We don't have to do that one, but so 6 minus 2 over 2 is minus 1. And here, chlorine has 6 minus 2 over 2 is 0. So chlorine has a formal charge of 0 right here. Now let's do the perchlorate. And perchlorate, to have an octet, to give one extra electron, we can assume that each oxygen has a single bond with chlorine. That is a minus. And again, each one of our oxygens, I don't know why I'm doing oxygen, is going to be the same. 6 minus 2 over 2 equals a minus 1. And our chlorine, which has 7 valence electrons, has 2, 4, 6, 8. 8 divided by 2 for a formal charge of 3 plus. Those are our two formal charges. Part B, that was A, was formal charges. Part B, let's change colors here, asks us what the oxidation numbers are. So let's do chlorine. There's a truck going by, sorry about that. This is minus 2. So this has to be a plus 1. That's the oxidation number of chlorine for the hypochlorite. And for my perchlorate, minus 2. So this has to be a plus. I've got one extra charge here, so that gives me a 7. That's negative 8, negative 9. So that's going to have a pretty positive charge here. Each one of my oxygens gives me a negative 8 plus 1 extra is minus 9. Or that's got to be a plus 7. So that's the oxidation number in the perchlorate. C asks us, is it unusual? Unusual for formal charge and oxidation number to differ. And of course, no, it's not. And the reason is oxidation numbers, I'm going to just abbreviate that as ox numbers, are based on complete transfer of an electron. So, for instance, O2 minus means 2 electrons are accepted by an O atom. 2 complete electrons. And formal charge assumes equal sharing. It ignores electronegativity. So it's not a perfect system either. Neither of those are perfect. D says perchlorate is a much stronger oxidizing agent. Than the hypochlorite. Chlorite. And why might that be? Would you expect there to be any relationship between the oxidizing power of the oxyanion and the oxidation state of the formal charge of chlorine? And yes, I would. So in ClO4, the ox number for chlorine was 7 plus, and the formal charge was 3 plus. Remember, an oxidizing agent causes a substance to be reduced or causes the gain of the electron. I'm going to write that again here. The oxidation number, and the formal charge was 3 plus. An oxidizing agent causes reduction, which is gain of electrons. Something that has a charge with a 3 plus or a 7 plus charge has great ability to gain electrons. Okay, we're done.